To find the margin of error, you need to use the formula E equals Z sub alpha over 2 times the square root of P hat times Q hat over N, where P hat, Q hat, and N are all under the square root, and Z sub alpha over 2 is our critical value. So there's a couple ways you can go about getting the critical value, either a table or your calculator, and I'll show you both. Choose whichever you think is easiest. We're going to find the margin of error where we know that N is 1,000, X is 400, and we have 95% confidence. So we got to find our P hat. Now P hat is easy to find. It's just going to be X over N. So in this case, it's going to be 400 over 1,000, which is going to be 0.40 or 0.4. And by extension, Q hat is 1 minus P hat, which is going to be 0.60. Now we got to find our alpha over 2 so we can find our critical value. So alpha over 2 is going to be 1 minus 0.95 over 2. And we do the arithmetic here, we're going to get 0.025. So we need to find our Z sub 0.025. So we can start off with, let's do a table. So we're going to go into a table, our z-score table, and look for the closest value to 0.025. So 0.025 is going to be right here. So negative 1.96, but we don't care about it being negative, we just want the value. So 1.96 will be our z-score, or critical value for this z value. So 1.96. Now if you wanted to use a calculator, very simple. All you're going to do is you're going to go to second invars, inverse norm, and for your area you're going to type in 0.025. And everything else stays the same or just is left blank. Hit enter and we get negative 1.959, so it's 1.96, but again we don't care about the negative, just the number itself. We just want the positive version of it. So you can use your chart or your calculator, whichever you think is easiest. Now once you have it, all we do is put it into our margin of error formula. So E equals 1.96 times the square root of 0.40 times 0.60 over 1,000. And here you just do the arithmetic. And when you do that, you're going to end up getting 0.030 as your margin of error for this. And I rounded to 3 decimal places, which I thought was enough, but whatever is required of you, you round to that far. Now this time we are 98% confident with a sample size of 1,230, and of which 40% are successes. So we don't actually have to find our p hat value. It is given to us, and again, like before, it is 0.40 or 0.4, which means q hat is going to be 0.60, and we still have to find our alpha over 2. So alpha over 2 is going to be 1 minus 0.98 over 2, which is going to give us 0.01. So we need to find our z-score of 0.01, our critical value, excuse me. So again, we're going to go into our table, and we're going to look for the closest to 0.01. In this case, it's going to be this value right here. It's a little bit closer to 0.01 than this one. So our critical value is 2.33. And again, if you want to use your calculator, simple thing to do. We just go to inverse norm, so second vars, number 3. And for our area, we're going to put 0.01. and hit enter, and we're going to get 2.33 again, just like we did before. So calculator or table, you will get this critical value, just whatever one you feel is easiest or more comfortable with. And now we're just going to do our margin of error. So again, we're going to do margin of error is equal to 2.33 times the square root of 0.4 times 0.6 over 1230. Again, we're going to do the arithmetic here, and when we do that, we're going to end up getting a margin of error of 0.033. In any case, whether you use your calculator or you use a table to get your critical value, once you find that out, figure out your p hat, q hat value, put your n in, put all your values in for your margin of error, and run it through, and be careful again, p hat, q hat, and n have to be under the square root. If it's not, you will get an error. So make sure you plug those in under the square root, and you will get your margin of error.